Okay, let's try that again.
You are graphing rational functions. Now, what does this mean to you? Rational. Fractions. You're going to graph fraction functions. Well, what it turns out to be, yes, they are fractions, but what happens is you have a polynomial on top and a polynomial on the bottom, okay? And this is the look you're going to get today. This is what you're going to get. What's the polynomial on top? They call it this, n of x. Now this is how your book talks, so I have to talk like your book so you understand your book when you look at it. N of x, what do you think the n stands for?
Numerator.
There you go. The numerator polynomial over the
D of x.
denominator polynomial. There you go. So when your book starts talking like this and you're reading it, you're going, okay, n of x is numerator, d of x is denominator. Then they say, okay, well, let's just look at what we're talking about. This is just a big review of the graph 1 over x. 1 over x was one of your parent functions back in chapter 1. I did ask period 4, what, do you guys remember it? It's the what? It's the reciprocal function. Now, let's try this. Let's just see what happens. If you want to know what it looks like, you just have to put numbers in. So if you put a number in like, let's say, 1, what do you get? 1 goes in, 1 comes out. Okay, so 1, 1. If you put a 2 in, you get 1/2. Okay, so 2 goes in, half comes out. If you put a 3 in, what would you get? 1 over 3, 1/3. Is this ringing a bell? A little bit? Okay, but what happens as you get closer and closer to the y-axis? You start putting in 1/2. Now, how many halves go into 1? 2. So the answer is 2. And so you go half. 2 is here. So you kind of have this look right now. Do you know what happens as I keep going to positive infinity with my x's?
It never hits.
Gets super
Never
close.
It gets super close to what?
0.
The x-axis 0. Okay, so basically it rides the x-axis out, okay? All right, now, as I approach the origin with my x's this way, I already did a half. If I did a third, what's the answer? It is 3. Okay, so there. Now what's going to happen as I keep getting closer and closer and closer to 0?
It's going to approach the y-axis. But never.
But it
You do
never
the same
touches.
thing.
It's just going to keep going what? To positive infinity, right?
Right.
Okay, so what happens is this. This is the y-axis. What happens is you, when you're looking at 1 over x, it doesn't penetrate the x-axis. It doesn't penetrate the y-axis. These are known as what? Asymptotes. Okay, you've got vertical asymptotes and horizontal asymptotes. The vertical asymptote is right here. Okay, there's your vertical asymptote. Will, stay with me.
Paul's looking at me.
That's vertical. Okay, now what's the equation to vertical asymptotes? X equals. Okay, what? 0. Because every x value on this line is 0. Now, here's how you're going to write this today. You'll go VA, vertical asymptote. Okay? There's another asymptote. It's the what? Horizontal. It goes this way. Okay, so this one is the horizontal asymptote. It will be y equals a number. Well, every point is 0 here. Every y value is 0. Good? Okay. Does that ring a bell? Okay. What about the other side? And when I say the other side, I mean the other side of the vertical over here. So if you plugged in negative x values, what happens?
It's a reflection over the origin.
Good. Yeah. 1, 1, negative 1, negative 1. So if I put in negative 1, I get out negative 1. If I put in negative 2, I get out negative 1/2. If I put in negative 1/2, I get out. Yep. There it goes. There it goes. Right? Okay. This parent was given to you in chapter 1. You did it. You worked with it. Then you probably forgot about it for a good month. Now we're back at it. Okay. So there's just a review of what you already know. At least I hope you know. Okay. Now, how wicked can this get? it can get pretty ugly. And this is why Monday, when you come here, I've got 8 of these for you to do. 8. This is what one could look like. You have to graph this. But here's how it works. You always have to look for horizontal, vertical, asymptotes, and then you have to kind of throw some numbers in to see where you're at. Do you see, maybe on your graph or maybe up here, do you see any vertical asymptotes?
Yes.
Yes, what?
X equals 0, and X equals 1.
Okay. So x equals 0 is right here. So horizontal asymptote, x equals, yes, you're right, vertical. Vertical is x equals 0. Oh, that's too big. Okay, so that would be VA. Vertical asymptote is x equals 0. And Paul, you did say this one, right?
Yeah.
Okay, this is what?
X equals 1.
X equals 1, okay. So you have 2 vertical asymptotes, okay? But there's another one. Not another vertical, I'm sorry. There's another asymptote. Do you see a horizontal?
Y equals X.
Y equals what?
X.
No.
Scale.
Okay,
Look at this.
I'm asking you this. Do you see horizontal? Is there a horizontal line that rides below or above?
Yeah. Oh.
Look at the y-axis. Well, kind of touched the y, okay. And then it went through the y, okay. So there is no horizontal. But there's something called, and you will do this on Monday, but not today. You won't do this today. But there is another asymptote. It happens to be what we call a slant asymptote. Now, I'm not sure. I know Algebra 2 regular did not do this. I'm not sure about enriched. You might have done slant asymptotes. You might have. I don't know. Now, I don't know if you heard this, but Paul said he thought it was y equals x, or I think you said that.
That's what I said. Yeah.
Okay, but it is. It's something like it has to have a slope to it, and it has to have a y-intercept. So when you do this on Monday with me, you'll say the slant asymptote might be, and I'm just making this up, guys, 1/2 x plus 1 or something like that. That's a made-up answer. Don't copy that. But on Monday, that's kind of what we're going to get. Don't copy that because that's not what it is. I just made that up. Okay? Now, this slide is only to tell you how complicated they look. They could get this bad. This would be a very, very easy one or a hard one.
Hard.
This one's hard. This one's hard. This would take you a long time. Okay? On a test, I'm not out to hammer you guys. I'll probably give you an average problem, not a hard one. Okay? All right. Here we go. Now this is kind of weird because this is talking about the definition of a vertical asymptote and a horizontal asymptote. I have a feeling there was a picture there.
There is.
Why is mine not showing? No, I don't think so.
Press like forward again.
Press what?
The forward, like the next slide button. When you were on it before.
Well, that didn't work.
It went away before I said that.
What are you doing?
You can't use your pen because the green is flashing.
Oh, is it? Well, it has been flashing all the time, hasn't it?
No, it just started flashing
Okay.
just now.
Okay.
I don't know how we're gonna get by.
Oh, look at this
You
mess.
should probably just leave.
Wow. Yeah. Okay. We'll get going. Hang on.